Thanks for joining me today. This is Danny, and welcome back to my modded 1.12.2 series. This is part 2 of our deep resonance setup. So in the last episode, we've started automating our deep resonance setup with creating the liquid crystal, and we started actually manually infusing the crystal to get it up to the parts that we want. Today we are going to finish automation of the infusion process and the rest of the crystal creation process, so that by the end of today, we should have a fully automated, completely hands-off system from start to end that's going to generate some really, really powerful crystals that are going to produce some crazy amounts of RF. First thing we're going to do is we're going to take a look at this program that I wrote to automate the infusion process that is going to put all the stuff in the infuser that we need. It's going to set the redstone that it needs to be, and it's going to make everything completely hands-off for us. This is going to be really technical and involved and detailed, and if you have a short attention span like I do, you might kind of struggle with it a little bit. However, if you really want to fully automate your deep resonance system, I'd recommend that you just bear with me and stick with it. So here's what I've got for RFTools Control. We've got a processor over here, and actually I'm going to put a lever on top of it because our program is going to be redstone controlled. And then I also have 3 nodes. Now these are remote nodes. We don't need any cables to connect them. This processor will be able to communicate with any machines or whatever that are touching these nodes. I've got one here that's right above the infusing laser. I've given it the channel address. I've given it the name infuser. Deep resonance is what that means. D-res. They're all on the same channel, and they all have different names. So this is the fluid node. It's right above our tank. And then I put another node down here, right next to our refined storage interface, so that it has access to all of our inventory in our refined storage system. And this one also, the D-res channel, is called RSint, meaning refined storage interface. So what we have to do is we have to go into our processor, and we have to say net setup and then the name of the network. So we're calling this dres. We hit enter, and it says it found 3 nodes. So hooray, it found all 3 of those nodes. So now I have a new batch of crystal in here, and I've played around with it a little bit, but you can see the numbers are not up to where we would want them to be, except for quality, of course. This program is going to change that. So I've got the RFTools Control program over here, which is where programmer over here. This is where we write the program. And behind the processor, I have a redstone proxy. This is basically going to allow us to read redstone into our XNet system. First of all, I'm going to give you a quick overview of how RFTools Control works, in case you're not familiar with it already. It basically gives us the ability to write programs using these little app codes. So instead of writing lines of code, each one of these little app codes kind of represents a line of code for us. It executes some sort of program action. And there are multiple different types of app codes. So the yellow app codes, these are events. These are basically triggers. So they cause the program to run. The blue ones are evaluation app codes. These are ones that give us some kind of information. We can check for redstone signals. We can do all kinds of different queries of things in the world. The red app codes are our test app codes. These are kind of our control logic. So these are basically going to return a true or false value, and they're going to change the path of the program based on what values we get, whether it be true or false. The green app codes are the operation app codes. These are the ones that actually do stuff. So these can move inventory around. Some of them will set variables. Some of them will wait or set redstone and do all kinds of stuff like that. The orange app codes are evaluation app codes, similar to the blue ones. But these are specifically for deep resonance. So this is mod compatibility between deep resonance and RFTools Control. So deep resonance actually adds these app codes to RFTools Controls. Both mods happen to be written by the same author. That's MCJD, who also writes a few other awesome mods that we use. So the way the program flows is with these little green dots. So like I said, it starts with the event. So the event triggers this program to run, and then we follow the little green dot to the next step. So all these ones on the top, they all have the green dot to the right highlighted, so the program is flowing from left to right up here, until we get over here where we start moving in some different directions, and we'll kind of take a look at that when we get there. So there are two things that can trigger this program, this first chunk of code up here. One of them is this event called redstone on. And what the redstone on event does is it executes a program when a redstone signal at a specific side or in general goes on. So what we're doing is, so when you click on these opcodes, you get the options for that particular opcode down here. This opcode, we select a side and we select a node. So remember, we have these nodes with these different names. If we want to use the processor is kind of like a node as well, but it doesn't have a name. So in this case, we're saying on the up side of the processor, we're looking for a redstone signal. So event redstone on. We also have the option to specify whether or not this should only run one simultaneous run. And I have this set to true. So what that means is that if this program is already running, it's not going to run it again. So it can only run once at a time. We can only have one simultaneous run. So when we get a redstone signal on the upside of our processor, this program is going to run. And on the outside of the processor, I have a lever. And when we flip that lever, it's going to trigger this program to run. The other thing that's also going to trigger the same program to run is this event signal that has the name check catalyst. So what a signal is, it's almost like a function or a go-to where we can use an opcode like this one here called send signal, and whatever signal we specify, it'll run the code that signal is attached to. So in this case, if we call the check catalyst signal, then this program is going to run again. And again, we're set to only one simultaneous run. So the first thing this program is going to do when we get a redstone signal or we get the call check catalyst is it's going to evaluate read purity deep resonance. So this is an opcode that will take a look at some deep resonance fluid, and it's going to give us the purity of that fluid. This is actually the main reason that we're using RFTools Control for this, because RFTools Control has the options that allow us to read the purity, strength, and efficiency. Nothing else really gives us that ability to be able to do that and then perform an action based on it. We are reading the tank adjacent to node fluid on the downside. So this node up here is called fluid. We're taking a look at what's underneath that on the downside, and that's this tank full of resonating liquid. So we're saying, hey, give me the purity of that tank. And then it's going to basically send that information to the next opcode. So we then move to this opcode, which is an operation that's setting a variable. And all this is going to do is it's going to take whatever the last opcode returned, and it's going to set that variable. So we're setting variable 0, variable number 0, to the purity. And then we're doing the exact same thing in the next 2 steps, or the next 4 steps. So we're reading the strength, we're setting that to variable number 1, we're reading the efficiency, and we're setting that to variable number 2. So we have to remember now, variable number 0 has the purity, variable number 1 has the strength, and variable number 2 has the efficiency stored within it. So then our next step is to evaluate the liquid in the tank. So we have this opcode called get liquid in tank, and what that's going to do is it's going to return the number of millibuckets in the tank that it's attached to. And again, we're looking at the fluid node on the downside. So it's checking that tank, and it's going to give us the number of millibuckets of fluid in that tank, which right now would be 16,000. The reason we're doing that is because our infusing laser will infuse whatever's in this tank, even if there's nothing in it. So if we put a piece of redstone in here or something and we give it a redstone signal, it's going to burn that redstone and beam it into this tank, and if there's nothing in there, it's just going to end up wasting the redstone. So we want to check to make sure, hey, is there anything in that tank? So we're getting the number of millibuckets of fluid in that tank, and then we're checking. We're using a greater than, is this greater than this? So our first value that we're checking is whatever the last function returned. So we can specify a constant number, we can specify a variable value, or we can specify a function. In this case, I'm specifying the function last int, which is saying what was the integer that the last opcode returned. In this case, that would be the number of millibuckets in that tank. And it's saying is that the number of millibuckets in the tank greater than 15,000? So that's just a constant value, 15,000. So we want to make sure, so we're basically saying, is there at least 15 buckets in this tank? With the greater than, or with all the logic operators, we're getting a true or false response. If it's true, it's going to follow the green path. If it's false, it's going to follow the red path. So if it's false, if it's not the case that there's at least 15 buckets in here, we're going to call the function called wait. So call function is similar to the send signal, and what this does is it basically goes to that signal. It triggers the signal, in this case the signal called wait. The call function will wait for it, so it'll stop this program from running so that it doesn't continue moving on or it doesn't get called again as long as we're running that function called wait. So I have a function called wait, and a signal called wait right here. So this is a completely separate signal triggered by the event wait. And all it's doing is it's waiting 60 ticks, which is 3 seconds. And then it is setting the redstone of the infuser to 0. So it's basically, if there happens to be a redstone signal going into the infuser, it's turning it off for cleanup purposes. And we'll see why it's doing that later, because we're using this function for some other stuff. But in this case, we're just turning the redstone signal off, and then we're reading the redstone on the top of our processor. So we're checking this lever to see if it's on or off. Because at that point, we're going to test the equality, and we're going to say if the last thing that returned, which was the redstone on top of the on top of our processor, which is the empty node name, if that's equal to 15, meaning that lever is turned on, then we're going to call the function, or we're going to set the signal check catalyst, which means, remember, we had two ways to launch this program over here. One was with the redstone signal, the other was with set catalyst. It's just going to go right back to the beginning of this program, and it's going to check this again. So we check the tank. If there's not enough fluid in there, then we go down here and we wait for 3 seconds, and then we come back up here and we check again. And it's going to keep doing that every 3 seconds until we have enough fluid in the tank, at which point it's going to move on to this, go in this direction. Now here I've just got a wire. It's called a wire, which is just an empty opcode that does nothing but allow you to move on to a different opcode. That just allowed me to fit the rest of this code in here. So then we move in this direction and we do another test. And this time we're checking we're doing a greater than value, and we're saying, is 10 greater than variable number 0? So remember, variable number 0 was holding our purity. So we're saying if 10 is greater than our purity, meaning our purity is less than 10, then we're going to call the function wait again. So that same function. This is a fail-safe. So remember, when we add a lot of our catalysts, we're going to be reducing our purity. And we don't ever want our purity to get really, really low, because if it gets down to 0%, we're going to start losing fluid, and that's going to be bad. So this is really just a fail-safe. It's saying, hey, if we don't have a good enough purity, we're just going to wait until the purity gets better. Eventually it will, because we have our purifier down here with filter material in it. So it'll just keep running through there until our purity is greater than 10, and then it'll move on. Now, that would probably never happen, honestly. Our purity will probably never get that low because the catalysts we're using, they're not really that harmful to our purity. But just in case, we want to have that fail-safe in place, because we don't ever want that to happen. So if this is false, meaning our purity is at least 10, then we're going to check our purity, or no. Then we're going to check variable number 1, which, remember, has our strength. And we're going to say, is 60 greater than our strength? So in other words, is the strength less than 60? If it is, then we're going to evaluate an item. So this opcode basically allows us to specify an item. And what you do is you click the little 3 dots here and you grab the item. So I had a redstone item in my inventory and I just clicked on it. And now it's going to send the item redstone to the next opcode. So we're setting a variable number 3, to redstone. And we'll see why in a second. So far we're using 4 variables. We're using variable number 0, 1, 2, and then now number 3, which is going to be set to redstone if this evaluates to true. And then we're going to call a function called setCatalyst. So the setCatalyst function is kind of where all the magic happens. So what this function is going to do is it's going to fetch items from an inventory and move it into our processor. So now RFTools Control is not capable of just grabbing an inventory from one place and putting it to another place in the world. It can grab items and bring them into the processor, into this inventory over here. So this is an inventory that we can put items in. And then it can grab stuff that's in the processor and move it somewhere else. So ultimately, we want to grab some redstone. We want to bring it into the processor, and then we want the processor to push that redstone out to our infusing laser in order to infuse our resonating liquid with redstone. So then the setCatalyst function is going to fetch some items from this inventory that's at the node rsint on the west side. So remember, we had that node downstairs called rsint. To the west of that node, which is in that direction, we had our refined storage interface. So it's going to grab an item defined in variable number 3. So remember, variable 3 was set to redstone here. So it's going to grab a piece of redstone. It's going to grab one piece of redstone, and it's going to put it in slot number 0. So the slot out refers to the slot within the processor. So the slot 0 is going to be this slot right here. And then the next opcode is to push items. So now we are going to push items into the infuser on the downside. So the infuser node, on the downside of the infuser node is the infusing laser. And we're going to put 1. We don't have to specify the item because there is only one item in there, and it's going to be whatever it's supposed to be. And it's going to pull from slot number 0 in the processor because that's where we put it. Right? And then it's going to set the redstone on the downside of the infuser node. So going into the infuser to level 15. So it's going to give the infuser laser a redstone signal after it puts the redstone in there. And then it's going to go to operation set signal, and the signal is going to be wait. So it put the catalyst in there, it gave it a redstone signal, and then we went down here to wait again. This is the same wait that we called before. We're going to wait for 3 seconds, which is about how long it takes to burn a single item in the catalyst, or to burn a single catalyst in the laser. And then we're going to turn the redstone signal off. And then we're going to check to see if our lever is still turned on, and then we're going to go back to send signal, check catalyst. So then we go back to the beginning and we run our checks again. So because it keeps checking this lever, that means that we can, if we want the program to stop, we can turn this lever off, and then the program will stop the next time it finishes its catalyst, which will basically be every 3 seconds. So then we go back to the beginning, we check. Again, is variable 1 less than 60? Is our strength less than 60? If so, then we put another redstone in there. And we just keep doing that over and over and over again until our strength gets up to 60. At which point this will evaluate to false, and then we'll move on to the next test, which is also variable 1. So we're checking our strength again, but this time we're saying, hey, is it greater than 70? So we know that we've gotten it to at least 60. So we've pumped all the cheap redstone that we can, because redstone is cheap. We've got tons of that. But now that we've reached the limit for redstone, because redstone will only bring us up to 60, now we're going to move on to 70 and start pumping some gunpowder in there. So it's the same exact concept. If 70 is greater than variable 1, we're going to set this variable to gunpowder. And then we're going to call setCatalyst again, and we're going to do the exact same thing. We're going to do the exact same thing over here with setCatalyst, but this time we'll be doing it with gunpowder. And then we go back to the beginning, and we keep doing that. We keep putting gunpowder in it, waiting 3 seconds, putting gunpowder in it, waiting 3 seconds, until we get up to 70, at which point this will evaluate to false. And then we move on to variable number 2, and we check to see if it's less than 80. So is 80 greater than variable 2, which remember is our efficiency. And if it is, then we're going to start pumping some nether quartz in there. So we're going to do the exact same thing, except this time we're going to do it with nether quartz. So once we get up to 80, so now our strength and efficiency are up to what we want them to be. But now, at this point, our purity is probably really low because we've been pumping in all this stuff that takes our purity down. So now we're just going to wait. We're going to call it the function wait if our purity is less than 85. So we're saying, hey, is 85 greater than our purity, which is in variables number 0? Then we're going to call the function wait. We're going to wait 3 seconds, and we're just going to keep doing that. We're going to check every 3 seconds. We're going to check, is it up to 85 yet? Is it up to 85 yet? If not, we're going to wait. As soon as it reaches 85, because remember our filter material, which is really cheap, it can get this up to 85 purity. So we may as well let our cheap filter material get this as high as it possibly can before we start putting in our expensive materials. So once our purity is up to 85, this will evaluate to false because it will no longer be true that 85 is greater than our purity. Then we check, we do another greater than check, and we say, is 100 greater than our purity? So now we're checking to see is our purity greater, or is our purity less than 100? And if so, then we add the catalyst. We change the catalyst to diamond. So we just set that same variable, variable number 3. All along here, we're using the same variable because that's the variable that our set catalyst function is looking at, variable number 3. This time we're setting it to diamond, and then we're calling the function set catalyst, which is then going to call the function wait, and we're going to keep doing that. We're going to keep adding diamonds one at a time until our purity gets up to 100%, and then this will evaluate to false, and then we're going to call the function called drain. So what drain is going to do down here is it's going to set a redstone signal on the west side of our blank node, which is the processor, to 15. So that's where we have this redstone proxy back here. So as soon as our fluid is what we want it to be, the purity, the strength, and the efficiency are all at least as high as we want them to be, then we're going to output a redstone signal to this redstone proxy, which our XNet system is going to pick up, and it's going to allow this tank to drain into this one, and it's going to stop this tank from filling this tank until, as we'll see, so it sets the redstone signal, it's going to wait 3 seconds, and then it's going to check the liquid in this in the tank up there, and it's going to say, is it equal to 0? And if it is equal to 0, then it's going to turn the redstone signal off, and it's going to send the signal wait, which is ultimately going to end up waiting 3 seconds and then bringing us back to the top to start the next batch. If it's false, so if this tank is not empty, then it's going to send the signal drain. So it's going to go back to the beginning. So it's going to keep looping here every 3 seconds while this tank is draining. So essentially the result of that is that we're going to be outputting a redstone signal into this proxy while this tank is draining until it is completely empty. And then once it's completely empty, all of it has ended up going into this tank. Then we're going to turn the redstone signal back on, which will then allow this tank to drain into this tank. Because we don't want this tank to be adding any crystal fluid and mixing crystal fluid into this stuff that we've already processed. Because then it's going to bring our purity, strength, and efficiency down. And then it'll mess up our next crystal. So that's the whole program. So let's see how this works. Now, like I said, I have a new batch in here. I've kind of skipped ahead to the future. We're going to go back to the past in a little while. I already have a crystal over here. So right now we've got some fluid in here. It has a quality of 100% because of our lava, because we kept that lava tank at the right level while we were creating the fluid. It has a purity of 85.1%, and that is because of our purifier and its filter material. It has a strength of 43.9% because I've already dumped some redstone in there while I was testing stuff. And then it has an efficiency of 10% because that's what we started with. So that nothing has happened in there. So if we put this program in here right now, what do you think is going to happen? So it's going to check and it's going to say, hey, do we have enough fluid in the tank? Yeah, we've got enough fluid in the tank. So this is going to evaluate to true. And it's going to say, hey, is 10 greater than our purity? No, it's not. Our purity is 85%. So we can move on. Then it's going to say, is our strength at least 60? So 60 greater than our strength. 60 is greater than our strength. So our strength is not yet 60. So we're going to put redstone in there. And we're going to call set catalyst. So that's what should end up happening. As soon as we put this program in here and give it a redstone signal, that's another program I wrote that we'll get to later, we should see that it puts a piece of redstone in there, and then it gives it a redstone signal, and then it beams it into here. And now our strength is going up, and our quality is going down a little bit. I mean, our strength is going up, our purity is going down a little bit. So that's how the program works, and it's going to keep doing that, of course, until our strength is 60%, and then it's going to move on to the next. I forgot to mention, when we set up our processor, there's 3 things that we're going to need to put in here. One of them is a CPU core. This is required for anything that you would ever do. We have the cheapest CPU core in here, which is going to allow us to run 1 program at a time, which is fine. That's more than we need. Well, it's exactly what we need. And then we also have a RAM chip in here, which is basically giving us these 8 variables. You could put multiple RAM chips in there if you want more variables. That's going to be more than enough for us. And then we also have this network card, and the network card is what allows it to communicate with the nodes. And then what we have to do is we have to allocate the variables and the inventory slots. And to do that, we click this little button up here, and that allows us to click on the variables and slots that we want to allocate to this particular program. And then I actually have another program in here that we're going to look at later that's using a different slot. So while this is going on, let me show you what we did in XNet. So remember, we're outputting a redstone signal into this redstone proxy. Once this tank has all the properties that we want it to have, and then we keep that redstone signal on until this tank is empty. So what I did in here is under the logic channel for the redstone proxy, I have 2 sensors set up. And one of them is checking to see if the redstone is greater than 0. So it basically means we're giving it a redstone signal. The redstone signal strength will actually be 15, but whatever, it's greater than 0. In that case, we're going to output color red. If it's equal to 0, we're going to output color green. So this is it's basically going to either be outputting red or green at all times, because when one of these is true, the other is going to be false. In channel 5, we have a fluid channel, and we're extracting from our raw crystal tank, that's this guy right here, on color green. So remember, green means that we are not outputting redstone from the back. So, and we're inserting into the crystal processing input, that's this thing right here, going into this tank, we're inserting into that also on color green. So when we don't have a redstone signal, XNet is allowed to extract from our source tank and insert into our crystal tank, basically our crystal processing tank. But once it has a redstone signal, once there is a redstone signal coming out of the back there, green will no longer be true and will no longer be able to extract from this tank and insert into this tank. So then we have another extraction process here coming out of that same tank, the crystal processing tank, but from the output, we're extracting on color red. So that means that there is a redstone signal coming out of the back of our processor, going into the redstone proxy, and we can insert into the crystal final tank, which is this one down here. The strength is now up to 70%. So it is now putting nether quartz in here. It actually was putting gunpowder in there for a while until it got the strength up to 70%. And now we're at the nether quartz, which is going to bring up our efficiency. Hooray. So we are now at 79.6%, which this thing is going to round up to 80 because it does round to the nearest integer, so that's fine. The last catalyst it put in was nether quartz, so it's now just going to wait. It's going to keep checking every 3 seconds for our purity to get up to 85%. Our purity is up to 85%, so it is now putting diamonds in there. Nice. I did actually make a small adjustment to the program. I made it faster. I changed the wait to 45 ticks, which is 2 1/4 seconds. I might actually be able to bring it down a little more even. I might be able to do 2 seconds even. Alright, it's draining. So as soon as we hit 99.5, it rounded it up to 100%. And then it drained it. Hooray. So now this is empty. And now you can see that it's starting to fill it up again from this tank, because the redstone signal turned off after this one drained. And the purity is already going up because of our purifier and the filter material. And now it's ready for the next batch. And it's going to start pumping redstone into it. Look at that. Awesome. And in the meantime, this thing is making more resonating crystal liquid, and it's going to put it in that tank for when this is done. This one is starting to generate crystals. So we are soon going to have our first awesome OP crystals. Hooray! Yay, we got our first crystal. But now we do have a few steps left before our setup is fully automated. We do need to get the crystal out of here and into our pedestal. And then once the crystal is spent, we need to get the spent crystal back into our infusing laser. And then we're also going to have to automate the turning on and off of the power gen here based on our power needs. Otherwise, we're just going to be wasting crystals. And we're also going to take a look at radiation. And we're going to do all these things in the next episode because we're kind of out of time today. I was hoping to get this all done in a single episode. But that's just not really happening. So I do hope you join for that. Of course, if you do have any questions, comments, ideas, feel free to leave them in the comment section below. And of course, if you did enjoy this, don't forget to click the like button and to join me next time. Thanks for watching.